Hello, Math 120. And this is Professor Gonzalez, and I'd like to take a look at some problems from homework assignment 2.5. And I don't know what the heck that was. The heck is that? Okay, that was weird. So 2.5, and I see my hand hit some magnifying glass. Anyhow, 2.5, and we're taking a look at the intersection and union of two sets, and more specifically, taking a look at how it pertains to inequalities, meaning graphing on the number line like on the x-axis. Let's start off at the beginning here. It says the word something implies intersection. So the word and implies intersection. And the symbol we use for that is this symbol for intersection. The word that implies union, so the word or implies union, and the symbol we use for union is this symbol right here. Okay, let's go down. Let me give a couple little examples, I think, just to start this off. If I have set A, and my set A is 1, 2, 3, 4, and my set B happens to be 2, 4, 6, 8, then if I was looking for the AND situation, so I'm going to say A, and I'm going to put intersection B. The word that works with this is AND. So if I use the word AND, say I'm looking for the elements that are in set A and in set B. And the elements that are in set A and B would be this overlapping stuff. So that's why we call it the intersection of the two sets. It's also AND works nicely with that. I'm looking for the elements that are in A and in B at the same time. And so then my answer would simply be 2 and 4. Now, if I was using the union on this problem, I'd say, okay, I'm looking for the elements that are, so if I said A union B, the English word could be or, that makes sense. I'm looking for the elements that are in A or B. Now, students sometimes will think, well, that means everything but the intersection, but that's not true. I'm looking for the elements that are in A, which would be what, 1, 2, 3, 4, or B. We already have 2 and 4 in there, so 6, 8. So the union just takes all of the elements in both sets, even the overlapping ones. Next question says, the intersection of two sets can be the empty set. That's true. Which one is it, B or C? Let's see, true, because the intersection of the two sets, one set is always empty set. No, that's not true. So it must be B. Let's read that one. True, because the two sets may not have common elements. Yes, that is true. So if I had set A, I'm going to say set A is 1, 2, 3, 4, and set B happened to be 5, 6, 7, 8. Notice there isn't any overlap. This is called mutually exclusive. And if someone said they wanted A intersect B, tell me the elements that are at A and in B, well, that would be the empty set, which you can show that way, right? Braces with nothing in it means no solution, or you can use the empty set like that, but basically no solution. What if someone had these mutually exclusive sets and wanted the union of the two? Well, that would be, I want the sets of A or B. That's going to be all of them. So once again, if it was the union, it would just be 1, 2, 3, 4. Maybe I'll zoom in. 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and so hopefully that helps you understand the difference between intersection and union and how we can use the word and or to make that make sense. Number 3, let A be this set 4, 5, 7, 8, 9 and B 4, 7, 8, 9. Okay, we want the intersection of the two, and so basically we want to see what overlaps. So you could actually kind of do that. Let's just do that, not with a Venn diagram this time, just by highlighting. So I see a 4 is showing up on both lists, so those are intersecting or overlapping. I'm looking for the numbers or the elements that are in set A A and B. So because it is, let me just specify, there's the intersection, which means and. Okay, still looking for more. How about a 5? Nope. How about a 7? Yes. I see 7 on both lists. I see an 8 on both lists. I see a 9 on both lists. So there's lots of intersection going on here. So the solution would be 4, 7, 8, 9. Okay, next one. Here's my set number 4. We're looking at number 4. We have set A and set B, and we're supposed to be finding the union, which means I'm looking for the elements that are in set A or B, which means we're taking all these elements. I noticed that MyMathLab doesn't care if you put them in chronological order. I tested that, so that doesn't matter, but I could also put them in order if I wanted, I guess. So 0, 1. So on this, we have 0, 1, 3, and 4. And then we also have 5, 6, 7, 8, 9. And that's finding the union. Okay, let's take a look at, let's see, so 0, 1, 3, 4, 5, 6, 7, 8, 9. Yep, there's the union. Okay, number 5. Let B equal 1, 2, 3, 4, and let C equal the set 5, 7, 8, 9. Find the intersection. So I'm going to go ahead, since I've got space, let me go ahead and draw this out. I've got set B and I've got set C. Let's go ahead and also see if we can find any of the overlapping. And I'm looking here, and I don't see anything overlapping, right? So if I were to draw these two sets, set B would be 1, 2, 3, 4. And set C, they're mutually exclusive, 5, 7, 8, 9. So if you want the intersection, where do they overlap? They don't. In other words, I'm looking for the elements that are in set B, and at the same time, those elements have to be in set C, and there aren't any. So the answer is B. The solution is the empty set. Number 6. Now what we'd like to do is take this idea of intersecting and union and intersection and apply it towards these graphs on a number line. So now our set is this set right here, and I think I'm going to use some color. How much space do I have to work with here? Good, I have some space down here. So let's use some color. I'll make this my red set, and that is set A. So set A essentially says x is greater than 1. And set B we'll do in green. Set B says x is less than 4. So those are our two sort of directives. X is greater than 1, x is less than 4, and this is our set B. Okay, so what they're looking for here, if I take a look at the directions, it says determine A intersect B. So we're looking for the intersection where they overlap. So now we're going to do this in Venn diagrams with these rings. We're going to do it with a number line. So that's how we graph these, right? So you want to put the critical values down. I always like to put 0 also. I'm going to put 0 right here. There's 1 and there's 4. There's our critical numbers, and our critical numbers are just the numbers from our inequalities. Now let me do the first one. We're going to do a sketch above. This is not our answer. This is just sketching it and trying to see where the overlap or where the intersection is. This first one, it says, here's how I like to say it. Shade the x values that are greater than 1. Well, greater than 1, is it to the right or to the left? And greater than 1, greater than is always to the right. So greater than 1, it doesn't say it's equal to it. It's just greater than, not equal to it. So we have to use a parenthesis saying that we're not including 1 in our solution. So there's the graph of the red, now of set A. Now I want to graph set B, which I'll do in green. Green says I want to shade, I'm going to shade the x values that are less than 4. What's less than 4? Well, less than 4 on the number line is to the left. So we go to the left, and it's not equal to it, so it's going to be open also, not including 4. Now remember, the problem said it wants A intersect B. Another way is to use the word and. I'm looking for the numbers or the x values that are in A and in B. And we can see the answer is actually going to be, I'll go ahead and do it in blue like the book, I guess. But there's where we have red and green at the same time. And it's all of this stuff in here. There's red and green. But once again, this is just green, but red is open, so we have to keep it open. It would have to be closed on both to be closed in our solution. So there's my solution, okay? And in other words, another way to think about this is this blue graphed information. If I take a value and they're like 2, 3, or 3.5 or 3.99, right? Anything in there within the graph section will make the red true and make the green true, right? Make the red true and the green true. That's why it's a solution. So now you can see what to select. Well, I just graphed it so I can see my graph is going to be A. So I'll go ahead and shade that. Also, it says, let's see, type your answer in interval notation. Well, these graphs are great for interval notation because you just copy them down and you got it. So this goes from 1 to 4 and it's open. And then type in your answer as an inequality. Well, how do you make this as an inequality? The way you make an inequality, now this is the x-axis. So the way you make an inequality, to keep it proper, you want your symbols, you want your inequalities to be facing, as you read from left to right, as less than. And if you do that, then this number will always be the smallest number on your graph, and this number will always be your large number on the graph, which also matches with our interval notation. So it's really nice to make sure you keep your inequalities facing, as you read from left to right, as less than, because then this will be true. And so then you just insert 1 here and 4 there. You're not going to put a line under there, because if you put a line under there, that would mean that 4 is part of the solution, and this would be a boxed endpoint, which would just say that it's part of the solution, right? It's including that endpoint. So anyways, there is our compound inequality, which we like to write like that when it's an interval. So the way you read this, though, is you kind of work from inside out. You say x is greater than 1 and x is less than 4. Okay, moving right along. Number 7. Number 7. Do I have space to work? Yes, I do. Awesome. Number 7, specifically, wait, did I have space to work? Oh, yeah, I do. Okay, sorry about that. Number 7, set A has it as x greater than 3. Set B, x is less than or equal to -4. Determine A union B. So we want the union of the two sets. So essentially what happens is you just write down both answers. But let's do this in a similar way as the last one, just so you can see the process. So my set A is determined by that inequality, and that's set A. So let's go down here and call that set A, and I already lost it out of my brain. X is greater than 3. X is greater than 3. And our set B is right here, which says x is less than or equal to -4. X is less than or equal to -4, and that's set B. So then we go and graph the two. on our number line. And I like the critical values. I put 0 about in the middle. Negative 3 is, I'm sorry, positive 3 is about there, which means my negative 4 is a little bit further to the left. And now I'm going to go ahead and make my graph. X. Shade the X values that are greater than 3. Greater than 3 is to the right. Because it's not equal, it's just greater than. It's open, not including. Let's graph B. B says shade the X values that are less than or equal to negative 4. Less than negative 4 is to the left. And it says it's equal to it, so we must make it inclusive. Now, if this was an AND problem, the answer would be the empty set, no solution. But it doesn't, that wasn't the question that they asked. If you go back to the beginning, they asked for A union B. So if we're looking for A union B, I'm looking for the numbers that are in A or B, which is going to be all of them. So that's why I said, really, when you're doing an OR problem, you could just write down the answer from the get-go. Now, if it overlaps, you don't want to draw it twice. That's the only thing, I guess. So my actual solution, which I guess I'll do in blue, the actual solution is just this. And this. Okay, so let's go up and match that answer with the graph. Less than or equal to negative 4, greater than 3, less than or equal to, so equal to negative 4. Oh, there it is. Less than or equal to negative 4, greater than 3. So it is A. A matches my graph that I just made. And what's next? Write the solution in set builder notation. Okay. So with set builder notation, the nice thing about that, it's not when you're not doing an interval, when you're doing something that has values going off in one direction and values going off the other direction, actually interval notation is harder, and set builder is probably a little bit easier. But all you'd have to do is copy down what I have in red right there. Oops, I have this in red, right? So I've got X is greater than 3 or, and then copy down the green, X is less than or equal to negative 4. And of course you could change the order of that wouldn't matter. And since it's set builder, you've got, you know, the fancy stuff on it too. So it should look something like that. So we've got to go up and pick what matches that. I need an X is greater than 3. So I need a greater than and I need a less than or equal to. I need a greater than and I need a less than or equal to. So I'm seeing, like right there, I'm seeing that I've got a match for this. Less than or equal to negative 4. Less than, right? Less than or equal to negative 4. And then I need the other one to be, so I need a less than or equal to, and then I need the other one to be a greater than, and the other one is a greater than 3. So the only difference was just the order, and that doesn't matter, right? I could have written it that way too. That doesn't matter. Okay, and so that's what they're looking for there. So the answer is B. And the reason why B worked is if you kind of work through the other ones, they have them facing the wrong way, or they've got an equal sign under it, so it's a, you know, an inclusive instead of not including endpoints, stuff like that. So when you look through it, you'll find that. And then finally, write the solution using interval notation. And this actually, interval notation is great for intervals, but it's not so great when it's not an interval like this one. So let's show this part right here in interval notation, right? That's going off to negative infinity. So it's negative infinity up to the largest value on that interval, which is negative 4, and it's closed. I'm just doing the blue. Now, this is an OR problem, so we use the symbol union, and then we go ahead and write that guy using an interval notation. Well, that's going to, the smallest number in the interval is 3, and that's open, and it goes up to positive infinity, and that's open. So there is the interval notation of that problem. So let's go ahead and copy that down right here. So it's going to go negative infinity up to negative 4, and that's closed. It was an OR problem, so we're going to put the union. And then I need the other interval, which was from 3 to positive infinity. Okay, moving right along to number 8. Now, number 8 is having us kind of step through it step by step. I'm just going to do the steps on the side, and then I'll just show you. This is just to kind of help guide you through it at least one time. So the difference on this problem and the last problem, the only difference is the last problem, notice we're already solved for x. You already isolated x. Whereas this problem, x is not isolated yet, right? X is not isolated yet. So we need to do that. So I think what I'm going to do is, because after they do that, they're going to have us do all this other stuff. So let's go ahead and use color for this then. So let's use color. We're going to make the first one red. And we don't have loads of space. So this one is 2x plus 7 is greater than or equal to 11. Of course, you want to you want to subtract 7 on both sides. And so then that gives us 2x is greater than or equal to 11 minus 7 is 4. Divide by 2, right? And x is greater than or equal to 2. I'm going to put a circle around that. Let's do the other one. Let's do the other one in green. Okay, and I'll put that right here, which is negative 3x plus 4 is less than 19. I go ahead and my first step, of course, is to subtract 4 off of both sides. And that ends up giving me negative 3x is less than 15. We divide both sides by negative 3. And you should be thinking, I don't know, big pink star, something cautionary. Watch out. Oops, I was in green. Because I'm dividing by a negative, when you divide by a negative, this inequality flips, and we get x is greater than 15 divided by negative 3 gives me negative 5. I'm going to put a circle around that. Now, remember the connector here? The connector here was and. Remember, and is the same as the intersection. Now, what do we just do? Let's see, we just filled out a bunch of parts of the problem, so let's take care of that. It starts here. This is my red problem, by the way. That's my red problem. And what did I have to do? You have to subtract 7 from both sides, just like I did. And then we got that step, which was 2x is greater than 4. And then it said divide both sides by 2. Divide both sides by 2. And we end up getting our answer, which was x is greater than or equal to 2. Then I did the same problem in green over here. The green problem, rather, is this guy. It's not the same problem as the red, but anyhow, there it is right there. And it says first is you want to subtract 4 from both sides. And I did that right there. When I subtracted 4 from both sides, we end up getting 15 on the right. And then it says divided by 3, and I did that. And notice they did that for you. I want that to be very clear that you had to change the direction of the inequality. And when we did that, 15 divided by negative 3 gave us a negative 5. So we're filling out that information. And then from that, I would like to use my work over here on the right to sketch, to make a sketch. Now, once again, my critical values, there's 0, there's 2, and there's negative 5. And now let's go ahead and sketch the red. Now this is an and, so we're looking for the intersection where the two cross each other. That's where our solution will be. Or the two overlap as like a layered pie or something, layered cake. So anyways, the first one says x is greater than or equal to 2. Well, what's greater than 2? Is greater than to the right or to the left, and greater than is always to the right on the number line. So we go to the right, But it also says equal, so that means we've got to include that with the boxed in endpoint, including 2. Let's do the green. The green says shade the x, whoop, what the heck happened there? Come on, this happens every once in a while. How do I get rid of that? Get out of there. That didn't do it. That didn't do it. I'm not sure what happened. No. Jeez. There it goes. Okay. Whew. Okay, now we're doing the green. And the green says shade the x's that are greater than -5. Well, greater than on the number line is to the right. So we're going to go to the right. And it doesn't say equal to it, so it's got to be open. But because this is an and problem, the only solutions that we get to use are the solutions that are in both green and red. And red, see the and word? So both green and red. So right here, starting at 2, we've got green and we got red because red is inclusive with the box. So our answer is going to be starting at 2, inclusive, and to the right, because that is the overlapping stuff. Now, when we graph it like this, it's so easy to make our interval notation, right? It just goes from 2 to positive infinity. And we already have a graph, so let's select that. It goes from 2 and up, so that's going to be B. It's going to be B. And then also, here's our solution as an interval notation. And our interval notation is right here, so this is going to be starting at 2 inclusively up to positive infinity. And then how would you say this in set builder as an inequality? Well, we say shade the x's that are greater than 2. They also have to be equal to 2 because it's inclusive with this boxed, okay? Boxed bracket or boxed parenthesis. Bracket, really. Okay, so this is my answer using set builder. X is greater than or equal to 2. So I go down here, set all x's such that x is greater than or equal to 2. All right, let's move on. Number 9. So this is going to be the same type of problem. I'm going to need a little space to work, and fortunately there's a little space down here. Let me do this one in red. So that is going to be down here, and that's 2x plus 2 is greater than or equal to 8. Now I need to solve that, so I'm going to subtract 2 on both sides, right? Which gives me 2x is greater than or equal to 6. Divide by 2 on both sides, and I get x is greater than or equal to 3. Awesome. Now we take our other one, our other inequality. We'll go ahead and do that in green. And that looks like this. Negative 4x plus 1 is less than 21. Solve, of course, by subtracting 1 off of both sides, which gives me negative 4x is less than 20. Dividing by negative 4 with inequalities, anytime you divide by negative, you should be very careful because it's so easy to forget. You must reverse the inequality, and 20 divided by negative 4 is negative 5. Okay, from this point, what we're going to want to do is graph it and go back and see, was this and or? It is an and problem, which means intersection, which means overlapping, right? We're looking for the intersection, and we can use the word and. I'm looking for the x values that are red and green. All right, so let's go ahead and graph that up here. My important values I see here would be a positive, there's 0, there's positive 3 there, and how about negative 5 out there? Okay, let's do the first in red. Red says, shade the x values that are greater than or equal to 3. What's greater than 3? To the right. It said equal also to 3, so we must include it with the bracket. Let's look at the green equation, or inequality rather, and it says shade the x values that are greater than negative 5. greater than negative 5 is to the right, and it is not equal to it, so it's not including 5, so it's open. And this was an AND problem again, so because it's an AND problem, we're looking for the solution. Our solutions are going to be the ones that are green and red, so that has to start here, and it goes forever this way, to the right. Of course, that's out to positive infinity, so if we're looking at our interval notation, that's from 3 to positive infinity. And that's our graph also, 3, positive 3. So that's what, 1, 2, 3. There it is right there. So B is the solution. And my answer, we said, was 3 to positive infinity. So interval notation, closed at 3, open at positive infinity. Anything else? Oh, yeah, they wanted the answer in Set Builder. And so we can say, can you say this in Set Builder? Yeah, it's shade the x's that are greater than, right, to the right, or equal to 3. So that just looks like that. So if x is such that x is greater than or equal to 3. And there it is. Now we move on. Number 10. Number 10 seems like it has way too many possibilities. Jeez, that's almost more confusing in some ways. Let's just do the problem and then write down the answer. Then we got to sort out which darn one it goes with. But let's see, do I have space to do the problem? I think I have enough to squeeze in over here. Let's start with red. I think I'm going to zoom in, so let's make the font size smaller. So here's my first equation I'm going to work, and that is 2x plus 1 is less than or equal to 5. I'm going to zoom in. Of course, subtract 1 on both sides, which gives me 2x is less than or equal to 4. I divide by 2, and I get x is less than or equal to 2. Done. Let's do the next one. The next one happened to be 3x minus 4 is greater than 20. 3x minus 4 is greater than 20. We're going to add, whoops, not that. We're going to add 4 to both sides, which gives us 3x is greater than 24. We divide by 3, and x is greater than 8. What was our connective word? Our connective word happened to be what? I can't remember. It was an or. So between these two would be an or. Also, we can use the word or the symbol union. So if I were to graph the two, you basically just graph both of them on your graph. But let's go ahead and take our time just to kind of show that. And I think I got to go down to the smaller font, and there we go. And so let's show both of these graphs. So it could have been straighter, huh? Can I make it straighter? Why does that bug me? That shouldn't bug me. It's not that important. Okay, so now we've got 0, we've got 2, and we've got 8 about out there. Let's do the one in red first. Shade the x values that are less than 2. Less than 2 is to the left. It says less than or equal to it, so we've got to include 2. And then the green says shade the x values that are greater than 8. Greater than 8 is to the right of 8. And it's not including it because it's not equal to it, so it's open. Now the word or says I want the elements that are in the red set or in the green set. Another way is to say union, take it all. So that means that all of it shows up in my solution. So the solution just is like this. There it is. These are supposed to be arrowheads, not anything else. Parenthesis, inclusive bracket. Okay, so if we're going to actually write the answer to this, well, we can see the graph already, and that's answered down there. But let's first match up where these would go, right? We got to figure out where the heck do we put our answer. And it just basically has to be the answer that has a combination of a less than or equal to and a greater than symbol, right? Which one has a less than or equal to and just a greater than? So less than or equal, well, that's the first one. Geez, it has a less than or equal to and a greater than symbol. So, well, it happened to be the first one, so we lucked out, I guess, in some ways. So I'm going to use this red inequality. X is less than or equal to 2, or, and then use the green statement, x is greater than 8. And that's it. So A was the proper format. The next thing to do is to, let's see, the solution set, type your answer in interval notation. Well, interval notation is a pain when it's not an interval, like this open interval. It's a little more of a pain when you got these OR situations, but it's negative infinity up to 2 closed union. This goes from 8 to positive infinity, and they're both open. So there's that, and that belongs right here. Oop. Union. Next, graph. Well, I have the graph right here. So you can see it right there, and it's -2 inclusive, so, and then we've got to use 8. C was looking good. C was looking pretty good, but the problem with C, right, notice that has to be open, and with C it's closed, so that doesn't work. But D looks really good. So I'm going to go with D because it is closed and going down just like my graph. Yep. And then it's open and greater than 8, which there's 1, 2, well, if we go back 10, 9, 8, and it's open. Yeah, so definitely D. Okay, moving right along here, number 11. Solve the compound inequality. The compound inequality, okay, well, does this one have space at the bottom? Perfect. It does have some space at the bottom, so let's do that. Let's use our colors again, just because it really helps our eyeballs focus in on what I'm talking about, I think. I guess you'll have to tell me if that's true or not. Here's our first inequality, and I need to stick with my pattern, which is not that big of a deal. Red. Did I do that in the last one? Just curious. Yeah, see? Okay, so the first is going to be red. And I take that inequality and write it down and solve the inequality. So this was just 4x minus, wait, ooh, do we have space for both? How many questions are on this one? Oh, there's 2 questions. And I might need that space for the next one. Yes, I do. Okay, I can't eat up the space there. But it looks like there's some space above this guy right here. I'll just use this. So we'll do some of this problem, some of this guy up here. So this is 4x minus 12 is less than 0. Of course, you add 12 to both sides, which gives us 4x is less than 12. Divide by 4, and x is less than 3. Excellent. Now we go to the next one, the next inequality, which is that guy. Negative 5x plus 4 is less than or equal to negative 16. By the way, in Math 120, Intermediate Algebra, often we start just verbally saying, or even just keeping it in our head, these steps, add 12 to both sides, divide by 4. If you want to show them every time, that's fine, but really don't have to show those particular steps. You could just show the result of it. But I kind of just show everything because of teaching. I don't know when people are having a problem or have a question. But typically we just start doing like this. At the green one, we'd say subtract 4 from both sides. So then you say, okay, well, that's negative 5x. And negative 16 minus 4 is negative 20. So you kind of do that in your head. Then the next step, you say divide by negative 5. Now, in this one, I probably would show it because it's so easy to forget that if you divide by negative, you got to reverse the symbol. So in that case, it's teaching-wise, it's good to really highlight that. But anyways, x, now we've got to reverse our inequality because we divided by negative. And we have x is greater than or equal to positive 4. Okay, space, let's see, I think I can go ahead and squeeze the graph right here. Let me try that again. Squeeze the graph right there. And so what are my important values? I've got a 0, I've got a 3, and I've got a 4. Maybe I stretch that out a little bit more because they're kind of close to each other. Let's call that 3. Well, 3 and 4 are pretty close to each other. So it's not to scale when I start stretching it out. But anyhow, let's do the first red inequality, which just says x is less than 3. Less than is to the left. And it's not equal to, so it must be open. And then we do our next one. This one says x is greater than 4. Well, greater than 4 is to the right of 4. And it is equal to it, so it must include 4. This problem said and. Okay, we got a big problem here. And means the intersection. So and means the intersection. So where do these two graphs intersect or overlap? They don't. So therefore, answer is the empty set or no solution. And what does our graph look like? Well, our graph, remember what our graph is. These blue graphs are basically saying those are the numbers on the number line that'll make the red true and the green true. Well, it turns out nothing makes the red and the green true. Some of these numbers down here make the red true, and a lot of these numbers up here make the green true, but there are no numbers that make the red and the green true at the same time. So our graph just has to be an empty old graph with nothing on it because nothing works. Okay. Number 12. Number 12 is a compound inequality, and it's written in this fashion. We saw this before, but I want to kind of review this again. The best way to tackle this, I think, the best way I would recommend to tackle this is to solve this in this fashion. So we've got a negative 7. In the middle, we have 4x plus 1. So with equations, to keep an equation balanced, whatever you do on the left, you must do on the right. Well, in this case, we really have, it's like a very, you don't have a left and right. You got a left, you got a middle, and you got a right. And all three of those must be kept in check, kept in balance. Whatever you do to the middle, you must do to the left and right. So if I want to isolate and get x by itself, if I want to get 4x by itself, I must subtract 1 in the middle, on the right, and on the left. And when I do that, I get negative 8 is less than or equal to 4x less than 17 minus 1 is 16. And then finally, I divide by 4 on the middle, the left, the right. All regions must be done. Negative 8 divided by 4 is negative 2. 4x divided by 4 is x. 16 divided by 4 is 4. Now this is in the proper form of a compound inequality that is an interval, meaning what is the proper form? Well, the proper form is that you have a less than symbol here and a less than symbol here, reading it from left to right at least, and that is the smaller number on the number line, and that is the larger number on the number line. That's really the proper form. That you can flip inequalities around, technically are true, but when it's this format, it's really the proper way to do it. And the nice thing about that is it really matches up with our interval notation perfectly, right? Equals means it's inclusive, so square bracket rather, and then less than but not equal to it means it's just open at 4. And so it's really kind of matches up with what we do. Let's go up here and fill in the answer. And the solution interval notation, which we said is negative 2 to 4. So negative 2 to 4, and we said that it's closed at negative 2, and it is open at 4. And I also graphed it already. No, I didn't graph it. But you can kind of see the graph in your mind's eye right there, pretty much, huh? You can kind of see the graph in your mind's eye right there because of the way interval notation works so nicely. That's squared off there, and it goes all the way up to 4 there, which is open. So what looks like that? -2 to 4, closed at -2, open at 4. That's not going to do it because it's closed, closed, closed at -2 and open at 4. That's going to be D. There's the answer right there. Okay, now I just want to give a little extra information, maybe to help settle some things in our brain. So these problems, when they're written this way, they're actually and problems. They're and problems. And you can hear it when I read this problem. And the way you have to read it, it's kind of a weird way to read it. I remember a trig class I volunteered to answer, and I read this answer in trig when I was going to a community college, and this would have been in 1987, just a couple years back. But I read it from left to right. So I said something like -2 is less than or equal to x less than 4, and the teacher said, that's correct, Mr. Gonzalez, but that reading was horrible. I was like, oh, thanks a lot. So really, the proper way to read it, and I learned that day, is to read it from the inside out. Is to say x is, now notice is opening up towards the x, so that means x is greater. X is greater than or equal to -2, and then read it this way from the inside out, and x is less than 4. Let me say that again. X is greater than or equal to -2, and x is less than 4. Notice there's an and there. So those are implied and problems. Now you don't really have to totally know that because you could just copy that down and solve it. But if I were to break it down using the word and like I said, it's really more work to do that, so I don't know, you probably don't need to do that, but it's kind of nice to have all that make sense in our head. So this part right here is one part of it, which just says -7 less than or equal to 4x plus 1. And then the other part that completes that and statement is right there, which is 4x plus 1 less than 17. And it's an and problem. Now, if we did this problem with an and statement, like we did all the other ands, and we did the intersection, you would actually come up with that answer right there. But this is already, it's already kind of made for us, so you might as well just take advantage and solve this. It's kind of a complex statement, but if you remember to do, remember to have that, whatever you do in the middle, left and right, and also remember to reverse symbols if you divide or multiply by negatives, then everything will be okay. All right, let's take a look at 13. 13 says, solve the compound inequality. So we've got the same kind of thing. And let's see, where did I do this space-wise? I try to show space. I don't have a lot of space, so I tried to sneak it in up there. Okay, so we'll take this problem and try to do it right up there. So then this problem says -3 less than or equal to. So the proper way, remember I told you the proper way? Proper way is read from the middle out, which would be 1/4 x minus 3 is greater than or equal to -3, and 1/4 x minus 3 is less than or equal to 1. Anyhow, the main thing, and I'm going to write this up again because it's new, is whatever I do in the middle region, I must do on the left and the right. So make sure that you keep up with that. And I'm going to go ahead and add 3 in the middle. So I've got to add 3 on the right, got to add 3 on the left. Well, this gives me 0 less than or equal to 1/4 x less than or equal to 4. Now, I could divide by 1/4, but easier yet would be to multiply by the reciprocal, because a reciprocal will turn that 1/4 into 1, and that's ultimately what we want. So we're going to multiply the middle by 4, the left by 4, and the right by 4. Well, 4 times 1/4, we pick that because it makes a 1x. And 0 times 4 is 0, and on the right-hand side, 4 times 4 is 16. So this is the compound inequality we have, and notice we have our format nice, meaning these are less than symbols, and then this is the small number, and this is the large number. So, if you want to write this as interval notation is what they're asking, well, it's easy, because interval notation puts the small number on left and the big number on right, and because it's equal to, it's inclusive, and it's equal there, so it's inclusive, so there's our interval notation. Ugh, got crazy there. There's our interval notation. It's closed interval from 0 to 16. We need the graph. In the graph, once you have interval notation, the graph is pretty easy. It goes from 0 to 16, and it better be closed and boxed, and I see that right there, right? 0 to 16, closed box, that's A. A is the solution, okay? Moving right along to number 14, another compound inequality. Be careful, this one is a what? This one is an OR, which means union. Okay, well, let's make sure we're careful, but let's take our inequality first and simplify it, or solve it rather. That inequality, whoops, someone would have told me in class, hey, red, oh yeah, red, dummy, oh yeah, okay, forgot. Wait, did I do red before? See, I'm just going crazy. Oh, wait, yeah. See, I get caught up on the dumb things. That's really not that important, but patterns, whatever. Maybe it does help the brain. Maybe it's me being crazy. But anyways, there's the inequality in red, which is x minus 3 is less than negative 4. I need to simplify that by solving that by adding 3 to both sides. X is less than negative 1. I'm going to circle that. Let's take a look at the other inequality, which says x plus 5 is greater than 6. X plus 5 is greater than 6. I subtract 5 on both sides, and I get x is greater than 1. Now remember, the connective word or symbol, the word is OR, and if you want to use the symbol, is union. Okay, so that means that both of those show up in my solution, right? And so if I took my time and I said, well, there's 0, there's negative 1, there's positive 1, and I did my stuff in red, shade the x's that are less than negative 1, not equal, so it's less than, it goes like that. And then I did in green, shade the x values that are greater than 1, not equal to it, so it's open like that. And I want to take the values in both of those, or the union, right? So then my answer would just be all of those values, just put like that. You're not trying to do any intersection, it's the union. So it looks like that, and it looks like that. Okay, do they want us to do the interval notation of that? Yes, they do. Interval notation of that's kind of a pain, but we'll do it. So it says, remember this is going up to negative infinity, so it's going to be negative infinity up to negative 1, and that's open, union. We like to use the symbol with interval notation, even though OR would do it. With interval notation, we like to use the symbol U, and for set builder, we like to use the word OR. Anyhow, then the rest of that is, it goes from 1 up into infinity, and that's open. So there is my interval notation. Plenty of little ways of screwing up the wrong symbol, isn't there? So that was A. And the graph of this problem, wait, what's going on here? Am I looking, oh, I'm looking at the wrong page. Okay, that's, wait, what problem am I doing here? Somehow I'm looking at, somehow I got union. Oh my gosh, okay, wait, this goes up here. Ah, okay. Oh my gosh. This problem that I did wasn't too 15, it was to 14. Dang, okay. No one told me. No one caught me. Anyways, when I look at the graph and I try to match my graph, it does work this way because this problem was problem number 14, which is up here, not down there. And so it goes from -1 to negative infinity, and it goes from +1 to positive infinity. And so still trying to figure out which number I'm on, number 14, right? And so that should be A. There we go. Yeah, that looks like it right there. And then if we take a look at our interval notation, right? Our interval notation should be this guy right here, from negative infinity to -1, union 1 to positive infinity. Yes. This iPad is like taking a look. You got to look at your work through a little window. There's my excuse. You get it? You catch that? Catch me trying to do excuse? Number 15. I'll try to stay on the right number this time. Number 15, and let's use our colors appropriately. Number 15, and this is going to be red. And do I have space? I don't really have space because there's a 16. So I'm going to try to squeeze all that stuff up here. So what I'd like to do is I'd like to actually take a step, do this with one step already done because I'm really limited in space. So I'm going to subtract 2 on both sides from the beginning. So now that gives me 4a is less than, and this is an a by the way, 4a is less than 0 because I subtracted 2 from both sides. Then I divide by 4, and a is less than 0. A is less than 0. Then I'm going to do the green equation. Same thing, I'd like to bring it up here and start with one step taken care of by subtracting 1 from both sides. So I've got -4a is less than or equal to, I subtract 1 from both sides, so it's 8. Divide by -4, be really careful, star. Divide by -4, which means reverse the inequality. That's -2. Now the connected word that connects those two is and, which we call intersection. You can use the word and. So remember, and or intersection means it's the overlapping. When green overlaps with red, that's my solution. So let's see if we can squeeze that graph in right here. There's not a lot of space. So my critical values would be 0 and -2. So let's, oops. So 0, let's write 0 there, and -2 right there. Okay, let's do the red. The red says, shade the a values that are less than 0. Well, less than 0 is to the left of 0, and it's not equal to it because it's just less than, so it's open. And then we do the green, and the green says shade the a values that are greater than -2. Well, -2 is right here, and greater than is always to the right on the number line, and it is also equal to it, so that's got to be closed. Now my solution is going to be the intersection of the two. So I go down here and I say, okay, that is red and green. So that's the beginning, closed. It's red and green all the way till I get to this location where it's green and not red, so it's got to be open there. Of course, interval notation is easy to work with this. It just goes, you just put your brackets there and parenthesis there, little comma there. So there it is. It goes from -2 to 0, and it's open at 0. Was that 0 or, let's see, yes, -2 to 0. We're on number 15. Okay, now let's find the graph that matches with that. That is going to be from -2 to 0, and it's closed at -2, and it's open at 0. That's got to be B. And we're down to our last question. Thank God. Okay, anyhow, what we want to do, we got some space. So let me rewrite this down here. And this says, negative, this says negative 21. We got less than or equal to negative 3 times the quantity x plus 6. That's less than negative 12. Okay, so make sure I wrote that down properly. Okay, so some people are going to have the knee-jerk reaction to distribute, and you wouldn't be wrong. And as they say, I wouldn't be mad at you. But I think it'd be easier just to get that thing out of there. Look at negative 3 is being multiplied by that whole quantity, right? If I want to undo that, just divide all pieces by negative 3. Now, the nasty thing about that is I got to flip those symbols, and now it's not the format that I like at all because it's this compound inequality with two inequalities, and they're facing the wrong direction. But let's work with it. Somewhere along the line, that's going to happen because of that silly negative. So let's just deal with it right now. And this gives us a negative 21 divided by negative 3 is 7. And I had to flip. And that reduces. And now I've got x plus 6. And so these inequalities must reverse. Negative 12 divided by negative 3 is positive 4. And so you could kind of see that there, in terms of the format, I got the big number on the left and the small on the right. So that's, if I just flip those around and reverse my inequalities, everything would be good again. But let's save that for the end. The next step is going to be subtract 6, middle, left, and right. That gives me a 1 over here. That gives me an x and a greater than and a negative 2. Now let's put this in the format that we really know it should be. That means let's put this negative 2 over here. Now I'm just going to tell you to flip the signs, and you might not believe me on that, but let me see if I can get you to believe me. If I were to just focus on this right here, right? It says x is greater than. See, notice the symbol is opening up to the x and not to negative 2. So if I put a negative 2 over here, the inequality still needs to be opening towards the x, just like it's opening towards the x there, right? And if I put this 1 over here, right? If I put that 1 over there, this inequality is opening up towards the 1, right? So if I put the 1 over there, the inequality to maintain the truth must still open up towards the 1. And by doing all that, notice I have my symbols reading left to right, less than, and I've got the smaller number on the left and the bigger number right. And that really puts it in just the proper format that any book would write it as, and keeps the confusion down and all that. And it matches with our interval notation. And by the way, they do want us to write the interval notation. Whoops, why did I make it conclude? Let's see, it should be open because it's not equal to it. And it should be closed to 1 because it is equal to it. So negative 2 to 1, it's open at negative 2. So we get negative 2 to 1, and it's open at negative 2, closed at 1. And then I look at the graph, going from negative 2 to 1, open at negative 2, negative 2 to 1, open at negative 2, closed at 1, open at negative 2, closed at 1. D is definitely the answer. And yay, we finished it. We're done with this, what is this, 2.5. I hope that helped out, and I hope you have a great day. We'll talk to you soon. Bye.